Good morning, class. Today lectures we're going to discuss about there is a topic. The name of that topic is general first order linear differential equations. Okay, so you know about the standard form of first order linear differential equation is standard form of linear first order differential equation is first order differential equation is dy by dx plus p of x of y is equals to q of x is equals to q of x. So in this equation there are two types of solutions. If q of x is equals to 0, then the equation is said to be a homogeneous. Okay, here q of x equals to 0, then equation should be homogeneous, and q of x is not equals to 0, then equation is inhomogeneous. Okay, then now in this equation there are two types of solutions. One of them is a complementary functions and another one is a particular integral. So the solution of homogeneous equation if q is to 0, this is called as a complementary solution or complementary function. So it means here we put q of x is equals to 0, that it means write equations dy by dx plus p of x of y is equals to 0, then the equation is, or solution of that equation is called as a complementary solution, or we call it that equation will be a complementary function. Okay, so let the solution of the homogeneous equations yn. Now here we consider the solution of that equation. Solution of equation yn. Now here we can just consider the solution of that equations is yn. So then we write equations dy by dx plus p of x dy by yn, because we find out the solution of yn. Dyn upon dx plus p of x of yn is equals to 0. So now therefore this p of x is here added, it goes to opposite side, then it will be subtracted. So we get such a types of equations. See, dyn of dx is equals to minus p of x yn. Okay, but thing is what, here is the function is a yn. Okay, it is in a numerator. Okay, and here is also yn is a numerator. So this yn is here multiplied, it goes to opposite side, then it will be divided. Okay, so modify this equation or rearrange above equation. Rearrange above equation. Rearrange above equation. So we get dy by dyn of yn is equals to minus of p of x dx. Okay, then we find the solution of this equation taking the integration of both sides, integrating both sides. So therefore integrations of dyn upon yn is equals to integration of minus p of x dx. Okay, and you know about there is a here we use the formula integration of 1 upon x dx. So same formula we use here, but here variable is yn. So therefore integration of this term will be written as a ln of yn, and now there p of x is a constant term according to you this equation. So that's why we write as like this minus p of x dx plus ln of c1. Ln of c1 is the integration constant. Okay, why we write here ln of c1? Because here is also ln of yn. Okay, so that's why we write the constant in terms of ln. It means log. Okay, so then now this ln of yn is here, ln of c1 is here added. It goes to opposite side, then it will be subtracted. So we get ln of yn minus ln of c1 is equals to minus p of x dx. Okay, here we are not taking the integrations of p of x dx because this is the function is the integrating, this is the integrating factor, and we find out that the solutions related to the complementary function. So you know the yn minus ln of yn minus ln of c1, then what happen? You know there is a property ln of a minus ln of b, it will be written as a ln of a upon b. The same formula we use for these equations. Okay, so we modified this equation. Okay, if we modified this equation, then what happened? Ln of yn upon c1 according to property is equals to minus p of x dx. Okay, but here we find out the values of yn. So how to find the values of yn? See there. Now removing log. Then what happens? If you remove the log, then equations will come as like this: yn upon c1 is equals to e raised to minus p of x dx. It means if we remove the log of both sides, then what happens? Here is not a log are there, so this term is written in terms of a exponential power. So that's why we get solutions. Therefore yn is equals to, now this c1 is here divided, it goes to opposite side, then it will be multiplied. So c1 e raised to integration of minus p of x dx. Okay, so now this is the solution of that complementary function, solution of that complementary functions. And now this e raised to term, that will be written as e raised to minus p of x dx or e raised to p of x dx. Simply e raised to, there is a minus sign because of we arrange these equations. So e raised to p of x dx is called a integrating factor. This factor is called the integrating factor. This factor is what? That is a integrating factor. So now this is what? This is the complementary functions or complementary solution of that given first order differential equation. So now we find out the particular integral solutions. Particular integral, that is simply called as pi, particular integral. So that is in short form we call it, that is pi, particular integral formation. So now the general first order differential equation, that is what? Dy by dx plus p of x of y is equals to q of x. Okay, so this is our equation. That equation we call it that a equation. Okay, so then we multiply this integrating factor by whole equation, multiply above equation by integrating factor, by integrating factor. So how to multiply this? As like this. See, this is integrating factor, that is e raised to p of x dx. So write e raised to integration of p of x dx into dy by dx plus p of x as it is e raised to integration of p of x dx into y, this y is equals to q of x e raised to integration of p of x dx. Or this equation is also written as d by dx of y into e raised to p of x dx is equals to same as it is q of x e raised to p of x dx. So why we write equation this type? Because you know there is a here is use a integrations rule, that is a u into v rule. In this rule what happen, there will be a first term as it is derivative of second term plus second term as it is derivative of first term. So that's why here we write, it means this total equations, this total term, this total term is simply what is written as a d by dx of y into e raised to p of x. If we solve this equation, then what we get? If we taking the derivative of this term, then what happened? dy by dx, derivative of first term, that is dy by dx. Second term as it is, that is e raised to p of x dx. Okay. Then first integration of derivative of first term, then integration is cancelled, and second term is as it is. So that's why we write this equation as like this. Okay. Then integrating both side, then what we get? Integrating above equation on both side, integrating on both side. If we integrate both side, then what we get? See here, y into e raised to p of x dx is equals to integration of q of x e raised to p of x dx plus c is a integrating constant. So now here I not write integration sign, because of what, you know, if you taking the integration of this term, then what happened? The integration and derivative was cancelled because it are exactly opposite. So that's why integration, if you take the integration, the integrated symbol and this d by dx, it will be cancel out. So we write directly y into e raised to p of x dx is equals to q of x e raised to p of x dx plus c. Okay. Now this factor is here multiplied. Okay, now we find out the values of that component y, similarly as like this. So how to find the value of y? So y is equals to, now this is multiplied here, this goes to opposite side, then it will be divided. It means this divided, then you write in exponential term, or the raised to power will be negative. So that's why we write equations e raised to minus p of x dx, right? Because this is here, this equation or this term is here multiplied, it goes to opposite side, then it will be divided, that is 1 upon e raised to p of x dx. But this 1 upon e raised to p of x dx is written in terms of e raised to minus p of x dx. Okay, minus p of x dx into q of x e raised to integration of p of x dx plus c into e raised to minus p of x dx, because this term is divided by both the equation, because here is a positive signs are there. That's why we write e raised to minus p of x dx, that is 1 upon, basically this term is what, that is 1 upon e raised to p of x dx, but we write in a numerator, there will be raised to power will be negative, so that minus p of x dx. Okay. So now this equation is representing the general solution of that given equations A. Okay, so how to, it means this is for the particular integral solutions of that given equations. It means first you multiply by that factor, integrating factor, after that we get such a types of equation, then we integrate the equations. If we integrating these equations, then we get as like these equations, and these equations is gives the what, there is a solution of that given equations, and you know it consists of two parts. The parts involving the general q of x is the particular integral, the second part is the complementary functions, and it contains the arbitrary constant c. So this is a arbitrary constant c. So now we modified these equations. How to modify these equations? So you know about there, here I write value of phi. So now the value of phi is equals to integration of p of x dx. So we now modified this equation, that equation is called as the equation b. So we modified this equation, then what we get? See there, y is equals to e raised to minus 5, because instead of this minus p of x dx we write a 5. So e raised to minus 5 into q of x e raised to 5 e raised to 5 into dx plus c into e raised to minus 5. Why here we write ds? Because the term is what, that is q of x dx. Here I am not write q of x dx or there. Here is also dx functions. Here is also dx. So that's why we write here. Uh, Here is also dx. This dx is different and this dx is different. Okay, so that's why we write these equations. Y is equals to e raised to 5 minus 5 q of x e raised to 5 dx plus c into e raised to minus 5. So this is the solution of that. E raised to 5 is the integrating factor and e raised to minus 5 is the complementary functions. Okay, so e raised to 5 is what? It is the integrating factor. Integrating factor, and e raised to minus 5 is a complementary function. E raised to minus 5 is a complementary functions. Okay, so this is the general theorem of the first order differential equation. There are some examples are related to this theorem. I will discuss on next lectures. Okay, if you have any doubt regarding that, then you can uh, send your doubt in comment box. Okay.